Jai Hind students. So this is the last video of complex topics of the subject wireless and mobile communication, which is running in BTech final year ECE. So the last topic is introduction to 5G and 6G wireless system. So let's start with the introduction to 5G. So till now we have discussed about the evolution of mobile communication from first generation to second generation, then third generation, then fourth generation. Now we are moving towards the fifth generation, which is now deployed in India. Not very large level, but yet, yes, it has started already. So we know that in third generation, we had the 3GPP. Okay, so 3GPP is third generation partnership project, which was extended in fourth generation, which is known as LTE advanced. And now in fifth generation, again, this 3GPP has been evolved. So 3GPP is the standard which is behind the 5G network architecture, which was introduced by third generation partnership project. And there is one organization which is known as International Telecommunication Union, ITU, which is basically deciding overall standards and the specifications for mobile and wireless communication. It also provides the timeline for starting of a new generation, like second generation, third generation, fourth generation, fifth generation, likewise for sixth generation. So it is the body which is regulating the complete standards and which is regulating the timelines, the specifications. So all these things are controlled by this ITU. 3GPP develops specifications for those requirements in a series of releases. So here we can see this fifth generation model, in which we can see all the applications which are currently used with the help of fifth generation network. So students, in this you can see basically there are three main categories, okay, starting from 4G low band, okay, and 5G DSS, then 5G mid band, sub 6 gigahertz, then 5G millimeter wave. So this is which is currently in use, which is currently deployed, which is basically compatible with the fourth generation and which has the introduction of fifth generation, which is known as 4G low band and 5G DSS. Then this is fifth generation mid band or sub 6 gigahertz, in which we are using the mid band frequencies approximately to sub 6 gigahertz. Then this one is, you can say, the complete deployment of full-fledged fifth generation network, which is known as 5G millimeter wave, in which we are using the frequency of the range of 24 gigahertz up to 100 gigahertz, or you can say in the terahertz range. This mid band is using a frequency range from 2 gigahertz to 6 gigahertz, and this low band or low coverage fourth generation plus fifth generation DSS is using frequency range from 600 megahertz to 2 gigahertz. So these are the three bands which I have discussed. So the first band is the topmost band, or you can say the complete or full-fledged deployment of fifth generation, which is not presently applied, which is 5th generation high band, also known as millimeter wave. Why millimeter wave? Because we are using frequency range starting from 24 gigahertz to 100 gigahertz, which comes out to be a millimeter wave range. So it delivers the highest frequency range, okay, highest frequency of fifth generation and the complete deployment of fifth generation, okay. Then these ranges are from 24 gigahertz to 100 gigahertz. Because of this high frequencies, it cannot easily move through obstacles, okay, because we know that as the frequency increases, the free space propagation loss also increases, the attenuation loss also increases. So if we are moving towards 24 gigahertz plus frequencies, then we cannot deploy high transmitting antennas. So in that case, we need to put small antennas, or you can say small base stations, okay, because these high frequencies cannot move through obstacles. So this 5G is a kind of short range in nature. So that is how, and that is why we need to deploy small base stations, or you can say these small base stations are known as micro cells and also pico cells. Okay, so which will be, moreover, this millimeter wave coverage is limited and it requires more cellular infrastructure, because as of now we are in fourth generation. So our base stations are made as per that requirement, which is of very high and large antennas are there. But if we are moving towards this fifth generation high band millimeter wave, we need to replace all those high antennas and high base stations by the smaller base stations because of this challenge. And what is that challenge? Challenge is because of the high frequency, losses will be higher, attenuation will be higher, and these waves cannot move through obstacles. Obstacles can be small hills, obstacles can be your high-rise buildings, it can be trees, it can be other kind of obstacles. So we need to deploy small base stations with a short coverage to get the high range frequencies, to get the fifth generation millimeter wave applications. So yes, so that is how we have two more options which we can presently use. One is fifth generation mid-band, operates in 2 to 6 gigahertz. Mid-band means we are not going up to millimeter wave as of now, so we have some middle range, and this middle range is varying from 2 to 6 gigahertz, which provides capacity layer for urban and suburban areas. Okay, and this frequency band has a peak data rate in hundreds of Mbps. Then we have a low band operation, which is more towards the fourth generation, okay, and very little towards the fifth generation. It is also known as fifth generation low band, which is operating below 2 gigahertz. It provides a broad coverage. Okay, coverage is high because the frequency range is low, so coverage would be higher side. This band uses spectrum that is available and in use for 4G LTE, essentially providing LTE and 5G architecture for 5G devices that are ready now. It means what presently we are using is the 4G in India, I am talking. So in India we are presently using the fourth generation, which is actually LTE advanced, okay, which is having a frequency ranges up to 2 gigahertz. So we are having a compatible fifth generation, which is also known as fifth generation low band, which is compatible with the existing infrastructure but providing you higher data rates. Okay, so the performance of low band 5G is not very high as compared to LTE advanced or 4G LTE, but yes, it supports uses for 5G devices on market today. So this is the architecture of 4G LTE, then 5G NSA, and then 5G SA. Okay, so starting from fourth generation LTE. LTE stands for long-term evolution. Here we have the LTE core or core network, then we have LTE RAN, and this is the user equipment. Okay, so this was for the fourth generation LTE. Now what 5G has introduced now is 5G NSA. NSA is known as non-standalone. Non-standalone means it is not completely deployed, it is also using some features of fourth generation and existing infrastructure of fourth generation. That is how it is known as 4G/5G NSA. And the architecture of 4G 5G NSA is like this. Here we have non-standalone user equipment, then we have LTE RAN and 5G RAN. RAN is radio access network. So both of the LTE and 5G are available with us. Okay, then this LTE RAN is connected to LTE core, okay, and this 5G RAN is connected to 5G core. So depending upon the application and the availability of the network, your device can switch. It can switch from 4G LTE to 5G NSA. I mean, it will be compatible with both. Whereas the evolution goes towards 5G SA, which is completely standalone fifth generation network in which your user equipment is standalone. It will not be compatible with the 4G. It will be using 5G RAN and then 5G core. Okay, so here you can say that this 5th generation standalone is the standalone architecture which will be using only 5G core and 5G RAN, right? So, here you can see that the earliest use of 5G technology will not be exclusively for 5G, but will also appear in different applications and which will be sharing the existing 4th generation LTE. So, that is how it is called as NSA mode, non-standalone, because it is also using the existing 4G LTE technology, right? When operating in this mode, device will be first connect to 4G LTE network, and if 5G is available, if it is available, signals are available, network is available, then your device will be automatically switched towards 5G and it will get the additional bandwidth. For example, if your device is connecting to 5G NSA mode, it could get 200 Mbps of downlink speed over 4G LTE and another 600 Mbps over 5G LTE at the same time. So, we'll get a complete bandwidth of 800 Mbps with the help of 4G and 5G altogether. So, this we have discussed. It is a new wireless standard after 1G, 2G, 3G and 4G. It enables a new kind of network which is designed to connect virtually everyone and everything, okay, together, including machines, objects and devices. This is the application. 5G wireless technology, it is meant to deliver higher multi-Gbps peak data speed. So, expected data rate would be multi-Gbps. It means not only 1 Gbps, we are expecting to get the 10 Gbps data rate. Ultra low latency. Ultra low latency means the delay would be very low in terms of milliseconds. More reliability, of course, massive network connectivity, capacity, increased availability of the network, and also more uniform user experience to more users. So, these are the, you can say, expected use cases of this 5th generation. Higher performance and improved efficiency, it empowers new user experience and connects new industries. It is a breakthrough, of course. The next generation of telecom 5G has started hitting the market. Okay, beyond speed improvement, the technology is expected to unleash a massive 5G IoT ecosystem where the network can serve communications needs for billions of connected devices. As we can see, with the help of IoT, we can connect our hardware with the network. So, we are expected to use this 5G technology to connect more devices, as we have, smart home appliances, we are talking about smart cities. So, all these things can be possible if we are moving, if we are emerging in terms of mobile generation also. So, this can be evolved with the help of 5G IoT. Okay. So, basically we can say that 5G technology is driven by 8 specification requirements. So, there are 8 specification requirements that are there with the 5G, starting from first about the data rate. So, expected data rate up to 10 Gbps, which is 10 to 100 times improvement from 5G and 4.5G network. 99.99% availability of the network, which is another requirement. Then 100% coverage, okay, 100% coverage is another requirement. 90% reduction in network energy usage. Network energy usage means, okay, so one part is energy which is consumed by your device, right, like your mobile. So, we are more concerned about the energy part. Up to 4G, we were more concerned about the energy part from that user device or user equipment. But from 5G onwards, we are also discussing the energy efficiency in terms of network part. Okay, so it is expected to reduce the energy consumption of the network by 90% in 5G, which was not discussed earlier up to 4th generation. Up to 10 years of battery life, okay, for low power IoT devices. Then 100 times number of connected devices per unit area compared to 4G LTE. Connected device means your smartphone, everywhere you have your Wi-Fi. Earlier we were not thinking about Wi-Fi in our cars, but it is available. We have AI generated our machines, other devices, fridge, everything is connected with your through Wi-Fi, your network. Then yes, 1000 time bandwidth per unit area. This is another requirement of 5th generation network. 1 millisecond of latency. Earlier it was of that latency was of 10 milliseconds in 4th generation, but in 5th generation wireless network we are expected to get a latency of 1 milliseconds. Latency means the time delay. Okay, so this I have already covered. Up to 10 Gbps data rate, 1 millisecond latency, 1000 time bandwidth per unit area, up to 100 times number of connected devices per unit area, which is compared to 4th generation LTE. 99.99% availability, 100% coverage, 90% reduction in the network, or it is more energy efficient as compared to 4G in terms of network. Up to 10 years of battery life for low power IoT devices. 5G speed tops at 10 Gbps seconds. 5th generation is 10 to 100 times faster than what you can get with your 4G phone, right? So here you can see the evolution. We can see the evolution in terms of the data rate. Okay, how we can see, like in 3.5G or in HSPA, we had 42.2 Mbps data rate. In 4G LTE, 100 Mbps data rate. See, here we are talking about the theoretical data rates. These are not practical data rates, right? This I need to mention here, because practical data rate is very different from the theoretical data rate, because the practical data rate will be depending upon the environment in which you are using that network, from which device is using that network. So there are so many factors by which your data rate or the practical data rate is driven. So these are the theoretical data rates. Okay, so in 4th generation LTE category 4, we were expecting to get 150 Mbps data rate. In 4G LTE advanced, okay, LTE advanced, the data rate were 1000 Mbps. Now in 5th generation, it is expected to get 10 Gbps of data rate. Okay, yes, shorter the frequency, larger the bandwidth, we know. So that's how, if we are increasing the frequency, then the bandwidth will be lower. So shorter frequencies, we are talking about the millimeter wave range, which is from 30 gigahertz to 300 gigahertz, for which 5G network is very fast because of higher bandwidth available. High band 5G spectrum provides the expected boot in speed and capacity, low latency and quality. 5G technology offers extremely low latency rate, we have already discussed. So the use cases associated with low latency, use cases means the applications that we can use with the help of low latency. Low latency means there is no delay, right? If we are talking about 1 millisecond, then we can say that it is not a delay, right? So with the help of this low latency, we can expect vehicle to everything. Vehicle to everything means you are on your car or you are in train and you are connected to every device, right? You are connected to your home appliances, you are connected to your car, everything. So that is the use case of 5th generation. Vehicle to everything, vehicle to infrastructure, vehicle to vehicle, connected cars, autonomous cars, okay, unmanned cars. So all these use cases can be expected to happen with the help of 5th generation. Immersive virtual reality gaming, remote surgical operations, or you can say the also known as telesurgery, simultaneous translating. So these are the features or the use cases that can happen with the help of low latency feature of 5th generation, which is of millimeter wave. Okay, now this is enough about the 5th generation. Now I have also introduced a flavor of 6th generation in this video. So we also discuss about the expectations from 6th generation. which is not really incorporated, it is under research. So if we are moving towards 5th generation to 6th generation, what are the planning or what you can say we can expect from 6th generation? So next generation VAR, holographic teleportation, it requires TBPS of data rates. TBPS you are talking, okay, TBPS. Till now we have 10 Gbps with the help of 5G millimeter wave communication. So it is expected to get a data rate of TBPS in 6th generation, also with microsecond level latency. In 5th generation, we have 1 millisecond latency, but in 6th generation, we are expecting to get the latency of micro level, that is microsecond level. Increasing industrial automation and move from industry 4.0 to upcoming industry 10.0 paradigm. So there is a paradigm shift in industry also. Till now we are talking about industry 4.0, but in 6th generation we are talking about industry 10.0 paradigm. Push connectivity density well beyond, it will be 10 to the power 6 kilometer square metric than 5th generation is designed for. An increase in connection density will also result in demands for improved energy efficiency. Yes, I mean, even 5th generation we are thinking about energy efficiency, but in 6th generation, because of the increase in density, we have to have very energy efficient network. So this is again another requirement. While ITU is working on a set of official recommendations for the KPI metrics, the tentative value have appeared in public domain recently as mentioned in the next table. So these are the expected KPIs of 5G and 6G. 5G are already established. These are the expected KPIs of 6th generation. So here we can compare both of them. First in terms of system capacity. So peak data rate 20 Gbps, here 1000 Gbps. Expected data rate 0.1, here 1. Peak spectral efficiency in bits per second per hertz 30 in 5G and 60 in 6G. Expected spectral efficiency 0.3 and 3. Maximum channel bandwidth in gigahertz, it is 1 gigahertz in 5th generation, the channel bandwidth 1 gigahertz in 5th generation and 100 gigahertz in 6th generation. Area traffic capacity in Mbps per meter square, it is 10 in 5th generation and 1000 in 6th generation. Connection density, devices per kilometer square, it is 10 to the power 6 in 5G and 10 to the power 7 in 6G. Now end-to-end latency in millisecond. So latency was 1 millisecond in 5G and it is expected to get 0.1 in 6th generation. Delay jitter, it was not applicable in 5th generation, but in 6th generation it is 10 to the power minus 5. Now system management. So at system level, we are expecting to get the energy efficiency in TB per joule in 6th generation. Reliability 10 to the power minus 5 and 10 to the power minus 9 in 6th generation. Mobility 500 kilometer per hour, and here we can have 1000. So what does it mean? If you are on a vehicle which is having a speed of 500 kilometer per hour, you can get your network. In 6th generation, we are expecting to get is 1000 kilometer per hour speed. So achieving these KPI highlights in the table, it will require revolutionary breakthrough in wireless communication and in all domain. So new spectrum usage, radio design paradigm will be required, novel network architecture will be required, increasing intelligence, automation, enhancing network coverage beyond terrestrial domain. Yes, in 5th generation also we are talking about the satellite communication. In 6th generation, we will look forward to have more in that area. Several enabling solutions are already there. Network operating at terahertz band with abundant spectrum resources, intelligent communication environments that enable a wireless propagation environment with active signal transmission and reception, pervasive artificial intelligence, that is AI, large scale network automation. So these are the enabling solutions of 6th generation. All spectrum configuration from front end for dynamic spectrum access, ambient backscatter communication for energy savings, Internet of Space thing. There is a new thing which is also expected to get is, now we are talking about Internet of Thing, but yes, in 6th generation we are talking about Internet of Space thing, which will be enabled with the help of cube satellites, which is of very small size. So launching those satellites, we can have the flavor of Internet of Space thing. Also UAVs means the drones. So we can have a communication with the help of drones, with the help of small satellites. Okay, so that is how we can be connected with the Internet of Space things. Cell-free massive MIMO. Okay, massive MIMO means we have studied about multi-input, multi-output already. So cell-free massive MIMO is also expected. 3 very promising technologies that are expected to shape the future of 6th generation communication are, first is the Internet of Nano Things, Internet of Bio-Nano Things, and quantum communications. So these are the areas in which research can be done to get the features of 6th generation. Okay, so here these are the key enabling technologies of 6th generation. Okay, 6G and B6G. So here if I'll talk about, this is 6G and this is beyond 6G I'm talking. So in 6th generation we have cell-free massive MIMO, in terahertz band communication, intelligence communication environment, pervasive artificial intelligence, network automation, reconfigurable front-end dynamic spectrum access, ambient backscatter communication for reducing the energy efficiency, Internet of Space things, and the UAVs. So these are the key features of 6th generation, and these are the beyond 6th generation. Beyond 6th generation we talk about quantum communication, we'll talk about Internet of Bio-Nano Things, we'll talk about Internet of Nano Things. So these are the beyond 6th generation key enabling technologies. Okay, so these are the use cases best served by 5G system. 5G introduced a targeted use cases which are intended to serve a wide variety of applications: enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. These are the use cases served by 6th generation network. Okay, so here emerging use cases for 6th generation network, you can see here. We have remote healthcare, we have a smart environment like your home automation, industry 10.0, right, industrial automation, then precision in agriculture, like we are talking about smart irrigation system with IoT, with AI. So these are the key features of industry 10.0. Then here we can see smart infrastructure in terms of UAVs. So we'll all be connected with the UAVs. Also holographic teleportation. This is also a use case of 6th generation, in which you can have a feeling of, if you're talking to someone on your mobile phone, then you can have a feeling that you are just standing in front of each other. So this can be done with the help of holographic teleportation. So this is another use case of 6th generation. Then we have space connectivity, yes, with the help of CubeSats. Autonomous vehicle, yes, this is another use case of 6th generation. These are the technological evolutions, and this is the timeline. I mean, by 2030 we can have the 6th generation test beds available. Thank you very much for patiently listening, and wish you good luck.